Welcome to Mikab Model College online tutorial. We hope at the end of this lesson, you will have acquired the expected learning outcome. Sit down and listen attentively as we introduce your subject teacher.
I welcome you back to mathematics class. My name still remains Adobazi Abdullahi, and in our previous class we discussed the laws of indices, and part of the laws of indices that we discussed the other time we met comprises of the one multiplication law, where we said if you are given a raised to the power of x times a raised to the power of y, the result of that is going to be a raised to the power of x plus y. That is multiplication law. And the second one we discussed is division law, where we said a raised to the power of x divided by a raised to the power of y is going to give us a raised to the power of x minus y. And from there we proceed to the zero law, where we discuss that any non-zero value raised to the power of 0 is going to give us 1. And from there we further discuss the laws of indices, where we said if we are given a raised to the power of minus x, the result of that is going to be 1 over a raised to the power of x. This minute we are going to discuss the other laws of indices, and the laws of indices that we are going to discuss this minute is power law. And in this power law we are going to discuss that anywhere you are given a raised to the power of x, open bracket, close bracket, or raised to the power of y equals, the result of this is going to give us this x multiplied by y. It means that this y has nothing to do with this a by the time you want to open this bracket. The only thing that you have that has effect on this y is this x. So you are going to multiply this x by y to give us the result of a raised to the power of x, y, and this a could be any non-zero value, and this x could be any value, and y also could be any value. Note that. In the application of this power law, we shall take a good look at simplifying the following, where we are given the first question to be open bracket x raised to the power of 2 close bracket or raised to the power of 3. The second question, open bracket minus 3 d raised to the power of 3 close bracket or raised to the power of 2. The third question is minus 3 open bracket d raised to the power of 3 close bracket raised to the power or raised to the power of 2. So the solution of the first question goes thus: x raised to the power of 2 close bracket and open bracket all raised to the power of 3. If you compare this one to the power law, this our x is going to be equals this a, and this 2 is going to be equals this x, this 3 is going to be equals this y. So anytime you are given this, it means that you are going to use this 3 multiplied by 2. The result of this x raised to the power of 2 or raised to the power of 3 is going to be x raised to the power of 2 or raised to the power of 3 equals x raised to the power of 2 times 3. Remember, these 2 and 3, they are both in power of this x. And by the time you multiply these 2 by 3, the result of that will give us 6. And the result of this x raised to the power of 2 or raised to the power of 3 is going to be x raised to the power of 6. That is power law. And if you compare this solution to this power law, where we are given a raised to the power of x or raised to the power of y equals a raised to the power of x or raised to the power of y, you will agree with me that this a raised to the power of x y here is still the same thing as this x raised to the power of 6 by the time you open these brackets. So we shall take a good look at the next solution of this question, the other way we can solve this question. And if you note this and you compare this to what you did in GSS 3, that is when you are dealing with index, you were told by them that whenever you are given 2 raised to the power of 3, you can express this one by having 2 times 2 times 2, which is going to give us 8. And if you use this to express this one, you are going to have x raised to the power of 2. You take this x raised to the power of 2 in position of this 2, and you take this 3 as the power of this x raised to the power of 2 in position of this cube here. So you are going to express this one in 3 places as x raised to the power of 2 times x raised to the power of 2 times x raised to the power of 2. The result of this x raised to the power of 2, close brackets and this open bracket, all raised to the power of 3, we are going to have x raised to the power of 2 times x raised to the power of 2 times x raised to the power of 2. And you agree with me that if you take this one back to multiplication law, where we said if you are given this x raised to the power of 2 and you are having another x raised to the power of 2 and the like of it being linked together by this multiplication sign, we are going to pick one out of this base and you write it as x here. Since the connectivity here are all multiplication, you pick one and add all the parts. That is how comes about this x raised to the power of 2 plus 2 plus 2. These 2 into 3 places represent the squares at the top of this x square, the 3x squared in this expression. That is our multiplication law. And by the time you add this plus 2 plus 2 plus 2, the result is going to be x raised to the power of 6, because the result of this 2 plus 2 plus 2 will give us 6. Therefore, you are going to have x raised to the power of 6. That is the solution of the first question. We can now proceed to the next question, where we have minus, open bracket, minus 3 d raised to the power of 3 close bracket all square equals, the result of this one is this. Recall that I told you in multiplication law that whenever you are given this mixture of number and alphabet, you are going to separate the two before you solve. And if you look at everything within this bracket is affected by this square outside. And by the time you expand, you separate this one from here, This one is having its own square differently from this d raised to the power of 3. And if the expression of this one using this will now be minus 3 all squares multiplied by d cube all squared. That is the separation of the number from the alphabet. Now, the expression of this one is going to be minus 3 times minus 3. And the expression of this one, if you go back to the power law, all you need to do here is just to multiply this 2 by this 3 as the power of this 3. And the result of that will give us minus 3 times minus 3 multiplied by this d raised to the power of 3 times 2. That is our power law. And by the time you multiply this one together, this minus will strike this minus, and 3 times 3 will give us 9. And by the time you multiply this 3 by this 2, you are going to arrive at 6. Therefore, the result of this is going to be 9 d raised to the power of 6. Alternatively, we may like to solve this this question using another method by expressing this in 2 places. This minus 3 d raised to the power of 3. We are going to express it in 2 places. The reason why we are expressing this one in 2 places is because of this 2 as the power of everything within the bracket. So, by the time we express this minus 3d cube all raised to the power of 2, we are going to arrive at minus 3d cube, which is the first one, multiplied by minus 3d cube. Remember, the connectivity between this minus 3 and this d cube is multiplication sign. So we are going to separate the number from the alphabet, and we are going to arrive at minus 3 times d cube multiplied by this multiplication sign, you break it down, minus 3 times, which is the connectivity between this minus 3 and this d cube. We are going to arrange the expressions, and the arrangement is going to be done in such a way that the number will be at one side while the alphabet will be at the other side. So when we have minus 3 and minus 3 being attached with this d cube, we shift them to one side, and we are going to have minus 3 times minus 3. Multiplication sign is the sign that links this d cube and this minus 3. Recall that, we bring it down. This d cube multiplied by d cube. So by the time you multiply this minus 3 by this minus 3, this minus will strike this minus, and 3 multiplied by 3 is going to give us 9. And by the time you apply the multiplication law here, we are going to pick one out of these 2 bases, and you write the down. You add, the connectivity here is multiplication, so we are going to add the powers. That is where we have 3 plus 3, and the result of this 3 plus 3 is going to give us 6. Therefore, we are going to have the result of this question is going to be 9 multiplied by d raised to the power of 6. The final result of this 9 times d raised to the power of 3 plus 3 is going to be 9d raised to the power of 6, as you remove this connectivity to make it formal. So you agree with me that the result of this alternative method is the same as the first method we used. You may like to try the two methods. So if you apply the two methods and you are not able to get the answer, then there must be something wrong somewhere. So we are going to solve the third question. Minus 3 into the bracket of d raised to the power of 3 close bracket or raised to the power of 2. If you compare this question to the previous one we solved, the previous one is having this minus 3 within the bracket. But in this case, it is only this d raised to the power of 3 that is within the bracket. It means that this minus 3 is not affected by this 2 as the power of this d raised to the power of raised to the power of 3. Sorry. Now, by the time you want to solve this one, all your attention will be everything within the brackets, and this minus 3 will be written along with it, and you are going to have minus 3 open bracket d raised to the power of 3 close bracket square. The result of that is going to be minus, remember, if you apply power law here, you are going to multiply this 3 by 2, and the result of this is going to be minus 3 d raised to the power of this 3 multiplied by 2. Remember, these 3 and 2, they are at the power of this d, and the result of that is going to be minus 3 d raised to the power of 3 multiplied by 2, which will give us 6, and the final answer is going to be minus 3 d raised to the power of 6. The only difference between these results and the previous one we solved is that this minus 3 is outside the bracket of this question. It has nothing to do with this square at the power of this d raised to the power of 3. But the previous one we solved, this minus 3 is within the bracket and is affected by this square whenever you are having it within the bracket before. So with this, I believe you are going to try more questions aside this one we've solved at home. We shall meet in our next class. Good day for now.